Have you ever wondered how submarines work? Submarines, those silent, sleek vessels that glide beneath the waves, have been vital players in naval warfare and exploration for centuries. These underwater marvels have shaped history, discovered sunken treasures, and even provided platforms for scientific research. From their basic design to their complex systems of buoyancy and propulsion, submarines represent some of the most fascinating engineering feats of our time. Well, you're in the right place to learn all about it. Before diving into how submarines work, let's understand their basic design and structure. At the heart of a submarine's design is its hull. This is the outer shell that protects the crew and equipment from the immense pressure of the ocean depths. It's typically made of high-strength steel to withstand this pressure. Next, we have the ballast tanks. These are crucial for controlling the submarine's buoyancy. They can be filled with water to increase the submarine's weight, causing it to sink. Conversely, they can be emptied by pumping in compressed air, which makes the submarine rise to the surface. Now let's talk about propulsion. Modern submarines use nuclear reactors or diesel-electric engines for propulsion. The nuclear-powered submarines can stay submerged for months without resurfacing, offering a significant strategic advantage. On the other hand, diesel-electric submarines are quieter, making them harder to detect. Another important part of a submarine structure is its control room. This is where the periscope, sonar systems, navigation equipment, and control panels are located. The periscope allows for surface observation while the submarine is submerged just below the surface, and sonar systems are used for navigation and detecting other vessels. Lastly, there are the crew quarters, storage areas, and other support systems that make life underwater possible for the crew. This includes everything from food storage to waste disposal systems. With this basic understanding, we can now delve deeper into how these parts come together to make a submarine function. The secret to a submarine's ability to dive and resurface lies in the concept of buoyancy. Now, what exactly is buoyancy? You've probably experienced it when you've tried to push a beach ball underwater. It's that upward force exerted by a fluid that opposes the weight of an immersed object. In simpler terms, buoyancy is the reason things float. It's a battle between two forces, the weight of the object and the weight of the water it displaces. When the weight of the water is greater, the object floats. When the object's weight is greater, it sinks. So how does a submarine, a massive steel machine, manage to float and even control its depth? Well, this is where the clever design of submarines comes into play. They are equipped with special compartments called ballast tanks. When a submarine needs to dive, the ballast tanks are filled with water. This increases the weight of the submarine, making it heavier than the water it displaces. Consequently, the submarine sinks. But what about when it needs to resurface? The process is simply reversed. Compressed air is pumped into the ballast tanks, pushing the water out. This decreases the weight of the submarine, making it lighter than the water it displaces, causing it to rise back to the surface. It's a delicate balancing act, constantly adjusting the amount of water and air in the ballast tanks to control the submarine's buoyancy. It's like constantly adjusting the weights on a scale to keep it perfectly balanced. Of course, this process is automated and controlled by sophisticated systems on board the submarine. It's a remarkable feat of engineering that allows these vessels to navigate the deep oceans with precision. So, that's how submarines dive and resurface. But how do they move underwater? That's a story for another scene where we'll explore the fascinating world of submarine propulsion and navigation. Moving underwater isn't as simple as it might seem. Submarines use a complex propulsion and navigation system. So let's dive in and see how these underwater marvels move around and find their way beneath the waves. Firstly, submarines move forward using a propulsion system, typically comprising of nuclear reactors or diesel engines and electric motors. These engines turn the propellers, and it's the propellers that push water out of the way, creating a force that moves the submarine forward. The faster the propellers spin, the faster the submarine goes. And if the submarine needs to reverse, the propellers simply spin in the opposite direction. But how does a submarine steer? That's where the rudder and stern planes come in. The rudder, located at the back or stern of the submarine, swings left and right. When it does, it changes the flow of water around the submarine, causing it to turn. The stern planes, on the other hand, control the angle of the submarine's ascent or descent. By adjusting these planes, the crew can make the submarine climb upwards, dive downwards, or maintain a level course. Now let's talk about navigation. When you're submerged beneath the waves, it's not like you can simply look out of a window to see where you're going. That's why submarines use sonar, a system that sends out sound waves and listens for the echoes. These echoes can tell the crew a lot about their surroundings, including the distance to nearby objects, their size, and even their shape. But what about the iconic periscope? Well, when a submarine is near the surface, the periscope can be extended above the water. It allows the crew to see what's happening above the waves without revealing the submarine's presence. It's a vital tool for avoiding danger and scouting out the situation. So, from propellers to periscopes, submarines employ a range of systems and technologies to navigate the underwater world. It's a delicate dance of physics and engineering, all happening far beneath the ocean's surface. That's a basic understanding of how submarines navigate the depths of the ocean. Submarines are marvels of modern engineering, operating in some of the harshest conditions on Earth. It's been a deep dive into the world of submarines, and we've navigated through their basic design, buoyancy mechanisms, and propulsion systems. With their robust structure, submarines withstand enormous pressure and offer a controlled environment for the crew, even at staggering depths. The magic of buoyancy and submersion, achieved through the manipulation of ballast tanks, is what allows these vessels to sink or float at will. It's a delicate dance of physics and engineering that keeps a submarine from plunging into the abyss. The propulsion system, meanwhile, is the heart of the operation, driving these aquatic behemoths through the ocean's depths. With advanced navigation systems, submarines chart their course, undeterred by the darkness and the unknown. So, the next time you see a submarine in a movie or on the news, you'll have a better understanding of the incredible engineering that makes it work.
Please do like, share and subscribe to my channel.